Welcome back from lunch. I hope you all had a good one. So this afternoon, what I'm going to do is really hone in on one of the effective teaching practices, productive struggle. And over the course of the next couple of hours, I'm going to actually engage you in some activities that will help better understand what this practice is all about. I think that of all of the 8 practices, this perhaps is the one that might be the biggest mystery to people because it isn't part of any explicit work the NCTM has done in the past. And we often think that if kids are struggling, then we've done something wrong, rather than intentionally trying to provoke struggle. So, the first thing I want you to do is I'm going to play a short video for you. And while you're watching the video, I want you to think really hard about something you learned to do, but you weren't very good at initially. Now, maybe it was math, but I'm guessing it might have been something else, in school, outside of school. So let's just only take about 2 minutes. So the question is, take the child diving into the pool. How did he get better? Or whatever it is you identified with. I'm going to guess it wasn't from listening to a lecture in a large lecture hall. It probably wasn't from sitting on the sidelines. It probably wasn't even watching an expert do it. So how does the child diving into the pool get better? Well, I would argue he gets better from opportunities to work hard while getting guidance from experienced others. And that's what we mean by engaging in productive struggle. So let's dig a little bit deeper into what productive struggle actually is. So the very first thing I did is I went to the dictionary. Well, not actual dictionary, I Googled it. Because nobody actually even owns a dictionary. And I looked up the word productive. And it said that productive was doing or achieving a lot, working hard and getting good results. And of course, then I had to look up struggle. To try very hard to achieve or do something that is difficult or that causes problems. So I put those together and came up with one version about how we might think about productive struggle. Working hard at something that is difficult to do, persevering when the going gets tough, and making progress. So in Principles to Action, we argued that productive struggle should be considered essential to learning mathematics with understanding, that it develops students' capacity to persevere in the face of challenge, and here I'm thinking about Standard for Mathematics Practice 1, which is really all about this. And it should help students realize that they are capable of doing well in mathematics with effort. The whole idea that effort creates ability. Hebert and Grouse argued that students expend effort to make sense of mathematics, to figure out something that is not immediately apparent. The struggle we have in mind comes from solving problems that are within reach and grappling with key mathematical ideas that are comprehensible but not yet well formed. So we're talking about problems not like the 2 Steve initially talked about. It's not about finding volume when you already know the formula. And it's not about doing the apples and boxes problem in its original format. We're talking about problems where you can look at it and you don't immediately know how to solve it. There isn't an immediate rule or algorithm that you can pull out of your toolbox and say this is one of those. You really have to think about it. In our own work, we've described productive struggle as comprising the work that students do to make sense of a situation and determine a course of action when a solution strategy is not stated, implied, or immediately obvious. From an equity perspective, this implies that each and every student must have the opportunity to struggle with challenging mathematics and to receive support that encourages their persistence without removing the challenge. And this is really important because a lot of times students who struggle in math aren't given problems that are going to cause them to struggle. We try to remove the struggle. We try to say, here's the way you do the problem, now here's your worksheet, work through these and I'll check your answers. And what we're arguing here is that every student needs the opportunity to struggle. That's how we get our identity as someone who knows and can do mathematics. Our challenge as teachers is how do we support students so they can work through the struggle without becoming so frustrated that they fold their hands, they put their heads on their desk, or better yet, start throwing things around the room. So what we're going to do in this series of activities is trying to look at the first two. What's the teacher doing here to actually support struggle? And we're going to pull out the goal sheet, which is called the S pattern task. So what you see here is a geometric pattern sequence and a series of questions. The ultimate goal in this task is actually to determine an equation for the total number of tiles in any figure in the sequence. So that's what I ultimately want you to get to. And that's what the teacher that we're going to be looking at is working on. So I'd like you at your tables to take a few minutes, really just a few, and play around with the task a little bit and see if you can begin to see some patterns that will be useful in answering this third question. So let me first begin by saying that I've seen this task used all the way from 6th grade to 12th grade. And what you would do with it depends a lot upon what your goals are for a lesson. But you might imagine how it could fit into curriculum almost at any grade level in middle and high school, depending upon what it was you're trying to accomplish. So I want to take a look at some possible solutions. You can probably see the picture, but you might not be able to see the writing if you're too far back. So let me just walk you through a couple of these. The first one I actually saw in my quick trip around this side of the room. I'm calling this one the rectangle plus 2 because it's really about recognizing that you've got these 2 extra squares, but the rest of it is a rectangle. And then just trying to figure out the dimensions, which would be x minus 1 times x plus 1 plus the 2. The next one I'm calling the inner square because it's about taking off the top row and the bottom row and recognizing that what you're left with there is actually a square and that you end up having n minus 1 quantity squared plus 2n that represents the top and the bottom row. The next one I did not see, but I suspect if I had given you more time and pressed you for more solutions, I would have. It's about filling in to make it a bigger square. So actually putting in extra tiles, then recognizing that you've got a square where the side length is n plus 1. You square that, but now you've got to take out the stuff you put in. So it becomes n plus 1 quantity squared minus 2n. The next one is really just taking the top row and relocating it along the side so that you simply have n squared plus 1. which is, of course, how all the others simplify. The last one is actually making a table and recognizing the pattern. And if you have done quadratics, you might actually be able to not even recognize the pattern and just what I would call by algebra brute force, figure out what the equation must be. But I would say making a table is probably the least interesting solution here, because when I see people make a table, they've collected the data from the picture, and then they completely ignore the picture, and the table makes no relationship back to what the shape of this thing was. And it becomes more of a matter of applying a procedure to come up with a generalization. So that background will help you as we look at what Jeff Ziegler's doing in his classroom. So at the time this video was made, Jeff was teaching 11th and 12th grade students in one of the Pittsburgh high schools. And this group of 11th and 12th graders struggled with mathematics. They all were in this class for at least the second time. So you might be able to relate to students who have that kind of challenge, but I think that's important background knowledge to have as you watch what's going on here. And his goal, Steve talked a bit about goals this morning. It's important to watch his lesson through the lens of what he was trying to accomplish mathematically. So he wanted his students to understand that an equation can be written that describes the relationship between two quantities, that different but equivalent equations can be written that represent the same situation, and that the symbolic and pictorial representations can be connected. So this goal setting, as Steve pointed out on several times this morning, is really important, and I'm reminded of something that I read recently. It was actually a quote from Yogi Berra, of all people, and I'm pretty sure he was not talking about algebra. But he said, if you don't know where you're going, you might end up someplace else. So if I think about the goal for a lesson, it's the goal that gives us the direction of where we're headed, knowing if we've gotten there. If we don't have a goal, we're sort of just aimlessly working, and we may not actually get to the point that we want to be at when the lesson's over. So let me just give you a little context. So the lesson begins by Ziegler engaging his students in a brief discussion of the task. They establish the fact that the S pattern is growing in 2 dimensions. As they said, it's both getting taller and bigger, so taller and wider. But before they begin work, Ziegler tells his students, and you can look at your task sheet here, there are 6 prompts. Kind of the first one, the second one, the third one is kind of to get you started. But it's on you guys to work with your groups to come up with a way to find the patterns. You don't necessarily have to word for word answer these questions, but they're there to help you maybe get started. What I think is so important about that is you can look at this task and think about it as Ziegler actually differentiated instruction through his use of this task. He didn't have kids doing all different things in the room, they were all doing this. What he's really saying is, we're going to talk about number 4. I've put the first 3 there if you need a little bit of scaffolding to get into the task. 5 and 6, you finish with 4, you've got something else to get you really thinking about what's going on here. So he lets students have the freedom to decide where they needed to begin this problem. Now, if you went to a student's desk and the student was trying to do number 4 and couldn't do it, he of course would suggest that they back up. But there's something about giving students the opportunity to decide where they need to begin and to provide like a low enough floor so that everybody could do something. Okay, there are actually 2 pieces to this, so we're going to watch the first part of it. Here you see Ziegler visiting 2 groups, his first visit to each group. What you think about while you're watching this video is what did Ziegler do to support his students' productive struggle?
Accomplish your X. That's constant. That's all we
Yeah, that's good.
You have to find a number that's before X to get to that. You already found what you have to add to get to that. You have to multiply that.
We figured this.
I don't know, yeah.
No, I can't do this. I can't factor. So we figured it out this week.
Okay, so you're gonna start with the table and see if you can find the equation from the table. Okay.
But we don't know how. We don't know.
I don't even know how to start to find the equation.
We know what the D is. We don't know if it should be X plus 3 or X plus an odd. Because it's X plus an odd.
Right.
These are all odds on the bottom.
Right.
All of them will be odd. And it's plus 2 between them. There's a difference of 2 between them.
Okay.
We already know the top rows are X. 1, 2, 3, 4. That's our X.
Right.
Or pandering. The growth is. I don't know what the growth is. The growth is an odd. It's like odd numbers.
Okay, so you have the table, you have these numbers written out.
Like we have the
That was
equation.
great. One of the.
Well, no kidding. Oh yeah, if I get the equation, life would be great. What do you have?
This.
Which is a what?
Yes.
Okay.
Pictures.
It has what?
Blocks.
Okay. How many?
26.
And number 5?
Yes.
Okay, that's 26. There's no other way you can come up with that number 26 than just count.
You can go by
So X
4 by
plus.
9.
He's
It's obviously much worse. So.
Do you guys know what he's doing?
Yeah.
I know.
All right, well, hold on. You did this. You don't know?
I was searching by myself.
Oh, okay. Do you know what he was doing? Okay, what's
I
this?
know.
It's whatever the pattern number is.
Okay.
Not even looking at this.
Okay.
Just whatever the pattern number.
Right.
You take it and you times it by 2 because there's obviously 2 rows. And the top row and the bottom row both have the number, this number 2. And then you times that by 2, that'll give you the top and bottom, and in the middle is a square. So
Right.
you might do 2, you do I'm gonna call this X. X minus 1 squared. That'll give you the middle, you just add them together. Did you understand that?
Yes.
And then I got another one though. If you take it, you go this way, rectangle. You take X plus 1, and you do X minus 1, and that'll give you this dimension right here.
Okay, just go back to the first one. There. Look at what he's doing. Tell me what he is doing.
What do you mean?
When he came up with, when he was explaining what the top row, the bottom row, and the second, do you know what he was talking about?
Yeah.
What?
I don't know how to say it, but I don't really know how to do it.
Okay. So tell me, show me. I mean, do you have it in your head, is it on paper?
And he said that, okay, the middle, there's one square in the middle, and then there's 2 on the top. Subtract 1 is to get the number, subtract 1 is square to get the number of boxes in the middle.
Okay.
So, X minus 1, so 3 minus 1 is 2, and then you square 2 to get 4 in the middle. And then you multiply the whatever sequence you're on, times 2 because you're on top.
Okay. And that's how you came up with the equation. So, okay, can you take his equation, it's 2x plus x minus 1 squared,
Figure 99.
and can you put it to a picture? Can you put it to these pictures? Like, let's pull out, let's say number 4, okay? If we take this, how does this picture right here relate to 2x plus x minus 1 squared?
So that's simpler.
You see what I'm saying?
That's simpler.
That's the easy way to break it down. You go from, you just take these things out.
Okay, so what I want you to do is just take a couple of minutes and jot down a couple of things that you think the teacher's doing that's supporting students' productive struggle. And if you don't think he's doing anything, then you can wait till you see the next piece and you can see if you change your mind. Just like 2 minutes. We'll watch the next piece and then you can have a little bit more discussion about it, and then we'll get together and see what we think about this. So here, he's going back to each of the groups that he just visited for the second time.
Okay, I'm back. All right, so when I left, I asked the group to come up and explain how we came up with 2x plus x minus 1 squared, and where that relates to the equation. So you ready to tell me?
Yeah. Well, actually, I think that creating a different equation might be versus that. Yeah, versus x squared plus 1.
Yeah, but then that's square.
What I asked when I left was 2x plus x minus 1 squared fit the pattern, correct? Okay. What I wanted to know when I left was, how does it relate to the tiles? Where is 2x in these tiles? Where is the x minus 1 squared in these tiles? Okay.
And so you just multiply 2 by that number.
Why? Why?
Because
The tiles.
it gets bigger. So it's not the answer. Yeah, it doubles.
What doubles?
The tiles. Like for 1 doubles. And for 2 doubles. 3 doubles.
Top and bottom.
That is it.
The X is the top one and the bottom.
What's the matter?
I understand that, I can't really explain it. Like those two.
If you want, see, my thoughts always were, if you really truly understood, then explaining would be easy.
Well, I do understand that. 2 is right here. That's where they got the 2 from. Like 2x. Because you just take out those 2. Use that. And then x minus 1 is like 4 minus 1. Oh yeah, which is how much is right there. They square it and that's how much is.
Okay, so take the sheet of paper right now. Take number 4. Separate. I want you to actually manipulate those line tiles on here. Show me the 2x. Show me the x minus 1 squared.
Alright.
Okay.
Then you add 1.
You listening?
Alright, you have 2 on the bottom, 2 on the top. You have that 1 in the middle, that's an extra.
Yes.
So you add that, that's
Yes.
plus 1. That's 2 and 2 is 4. That's 2 squared is 4. You add this extra one in the middle, that's 5.
Okay, what is he telling me here? Where x squared is 1?
For me or
Yeah, I'm asking you.
I get it. It's like because you start off with 1,
Yes.
and then you have the rest of them, and you add 1.
Okay.
And you just keep going. You want me to keep going?
No, what I want you to do is I want you to take these black tiles that are sitting right here. And I want you to show me where do you see 2 squared? And then where's the plus 1 there?
Like
Where's the 2 squared?
right here,
What's
right
that?
here, these 2.
Okay.
And 1 in the middle.
Okay, so for number 2, for pattern 2, top row and the bottom row, you're putting those 2 together, making a square and adding 1 to it. So if I did the same thing in pattern number 3, I took the top row and the bottom row and I put them together. Is that 3 times 3? And is there 1 left over? So what I'm telling you is, how do you manipulate these tiles for your x squared plus 1?
I mean,
If it obviously works.
1, 2, 3, 1, 2, 3. We're just doing it like that. And there's the 1 left over.
You can do that.
No, this is I can do it.
And then I see the I can do it. I'm not doing
Okay, you have, how many tiles do you have in pattern 3? How many tiles do you have in pattern 3? Okay. I'm giving you 10 individual tiles on this piece of paper. Okay? They are not touching.
Draw a new
I want you to take those 10 tiles and I want you to show me how you put them together
to make.
to get x squared plus 1. That's what I want you to show me.
We can go like this. Look.
I'll be back.
Oh, stay with us.
I'll be back.
Okay, so now that you've seen, we're not going to see anymore, that's the end of it. But I'll tell you about the punchline after you have some time to discuss this. So what I want you to do is thinking across both episodes, the visits to both groups 1 and 2 twice. What do you think he was doing to support productive struggle? Was he supporting productive struggle? Let's take about 3 minutes and talk about that in your groups, and I'm going to wander around over here a little bit. Lots of different things you might have noticed here. I guess I'd say the most important thing he did was what he didn't do. When students, and this was true in both groups, when all the students couldn't immediately do what he wanted, that is, create an equation, that was goal 1, that relates the 2 variables, and goal 3, which was connect the pictorial and the symbolic, he did not tell them what to do. Now, in a lot of ways, you could look at that and say it would have been more expedient if he had just told them what to look at. Look at the picture. Can you see a familiar shape in there? Can you relate the familiar shape back to the figure number? Any of those kinds of questions might have made the entire lesson go more quickly, but I think then we have to ask ourselves, what would be the residue that was left behind with students if he walked them through how to do it? And I'll tell you, the residue that gets left behind in those circumstances is this. If I can't do something and I wait long enough, the teacher will tell me how to do it. And it's kind of a learned helplessness that we reinforce, not intentionally of course, when we tell students how to do something so that they can get beyond the impasse they've reached. I also notice people saying things like, he had a good poker face. I think that was the language I heard. He basically was smiling most of the time, not just when somebody gave him the right answer, but he was trying to be encouraging sort of in his manner. You might have actually noticed too that he either sat at the group with the group or he lowered himself so he wasn't hovering over the group. And I think that also sends a message that I'm really listening, I'm making eye contact with you. I'm not just doing a hit and a fly guy where I'm going to listen up here and then leave you. You might also notice that every time he visited a group, he asked a lot of questions. I've heard that come up many times, and he left them all with something to work on. So he didn't hover over a group forever, waiting for them to get the answer. He asked enough questions so that he could understand what they were thinking, where they were, and then he left them with something to continue to work on. Now, group 1 in particular, you might have noticed, he's leaving us. And then the next time, I'll be back. That they weren't thrilled with him leaving, but when you walk away at a moment where students are left with something else to pursue, you're sending the message that I think you are capable of doing this without me breathing down your neck. And I think a lot of times, students get all kinds of nervous and jerky when they're working on problems that they're not sure about. Even sometimes we do that, and we want to know whether we're right or not. And what he's trying to do is to build this confidence to persevere, and also this identity that I am capable of doing this.